We are back to solving problems in arithmetic sequence, in particular finding the missing terms and finding the common difference, or maybe even finding the first term given a few terms down the sequence. You know what? The problems that we solved last time, they seem to be kind of difficult, given that maybe I think it's kind of difficult for newbies who are into arithmetic sequence. And you would feel bad. You would feel bad if you are capable of solving difficult problems, but you will miss solving problems which are a lot simpler. And so we will pay attention to two problems that are relatively simpler compared to the problems that we solved last time. So this one is about filling in the missing terms. So we are assuming that this is an arithmetic sequence. Okay, so this is exercise 2.3. So this is number 15. 15 here is not part of the sequence. So fill in the missing terms, assuming that this is an arithmetic sequence. Well, we can get the common difference from these two terms because they are consecutive terms. So what is D here? What is D? So D is equal to -1 minus 2, it's -3. Negative. The common difference is negative. So this means this is a descending sequence. This is like climbing down an escalator. So let us fill in the missing term. So what do you think should be the first term here? If this is 2, and the first term minus 3 is 2, then 2 plus 3 will be the first term. 5 is our first term. So 5 minus 3, so that's 2. 2 minus 3 is -1. -1 minus 3 is -4, and then -4 minus 3 is -7. So that's it. Those are the first 5 terms of our arithmetic sequence. The common difference is -3. Okay, how about this one? Exercise 2.3, fill in the missing terms. So I'm going to present here two solutions. What I did here is I simplify this. So the first term is square root of 2. Square root of 8 actually can be written as, okay, look at that. It's square root of 4 times 2. So that's going to be, the square root of 4 is 2. So 2 times square root of 2. Square root of 2, 2 times square root of 2. But how about that one? Okay, so 32 is 16 times 2. 16 is a perfect square. Square root of 16 is 4. So we can write that as 4 times square root of 2. So this sequence is equivalent to this one. And we can see right away the pattern here. So this is like 1 square root of 2, 2 square root of 2, 3 square root of 2, 4 square root of 2, and 5 square root of 2. So that does it. Okay? But then again, you must understand that in examinations, maybe the choices are not in this form. Okay? Maybe the choices are not in this form. But what if they are written in this way and the choices should conform to how these terms ought to look like? So do you know the common difference here? So this is an arithmetic sequence, but do you know the common difference? When I was about your age, I probably wouldn't be able to tell what is the common difference because I wouldn't know. I wouldn't know how to perform subtraction involving radicals. But this one is actually square root of 2. The common difference is square root of 2. Why? Okay, so look at these two pairs of consecutive terms. 2 square root of 2 minus 1 square root of 2 is equal to 1 square root of 2. So the common difference is square root of 2. Okay, so actually we are already done. But maybe in your exams, the choices are not written in this way. Okay, because the original sequence is not written in this way. So let us see what we can do. So the common difference is square root of 2. The third term, the first, the second, the third term is just like what we saw here. It's 3 square root of 2. But you know what? That 3, you can put it inside the radical sign, but it's going to be 3 squared. So that's 9. So that's going to be square root of 9 times 2. That's square root of 18. How about the fifth term? We already showed it's 5 times square root of 2. But if you were to write 5 inside the radical sign, it's going to be 25. Okay, so square root of 25 times 2, that's square root of 50. So it's possible if you see this in your major examination and the exam is a multiple choice type of examination, maybe you will not see this among the choices. So the third term is square root of 18 and the fifth term is square root of 50. Okay, so I'm showing that again. I'm showing back again the sequence and the missing terms. Okay, I will show you another pattern again. Okay, so we can write this as 1, the radicand, 1 times 2. This one is 4 times 2, or 2 squared times 2. This one is 4 squared times 2. So you can see what's missing here. It's the square root of 3 squared times 2. This one is the square root of 5 squared times 2. Okay, so this is just pattern recognition.